We'll look into a little bit more on information on glycolysis and exactly how much ATP that we form from glycolysis. Because that final number of how much ATP we form is very important. And there's many questions on how much energy do you form from glycolysis. So remember how we eat sugar or we eat carbohydrates, we break it down into glucose, which is the same thing as sugar. This glucose goes into our cell. So we have glucose inside the cell. Remember, it happens in the cell cytosol. Very important. So glycolysis of the glucose is now in the cell's cytosol. So we have glucose chilling out in the cell cytosol. Now we have to break this glucose down to pyruvate. So it goes through many different processes and we form pyruvate. So we'll just skip all the processes and go right to pyruvate. This is not metabolism, so we're not going to talk about each individual step to get from glucose to pyruvate. There's like 9 different steps. We're not going to talk about them. So we're getting from glucose, and then we have pyruvate. So we go through a bunch of reactions. We have pyruvate. Pyruvate, like we said, can go either through aerobic, which is slow glycolysis, to the Krebs cycle, or can form lactic acid, which we call, which is the fast cycle or aerobic respiration. Now the question is, well, we already know why we would prefer fast glycolysis or aerobic over anaerobic, because aerobic means we need energy extremely fast. Aerobic means we need energy slower, so we can go through the Krebs cycle. So we need anaerobic means we need energy extremely fast. But what is the purpose, or what is the what is the consequence of forming lactic acid? What is the consequence of going through anaerobic respiration? Now remember, going through anaerobic respiration only forms 2 ATP. It's very important. Now, if you remember from metabolism, the actual process of going from glucose to pyruvate, first you lose ATP and then you gain 4 ATP. But the end process is, just forget all those numbers I just said actually. The end process is only 2 ATP from anaerobic respiration. When you form lactic acid, the consequence is you only form 2 ATP. But it's still more ATP than when you started. So thus it gives you energy. Although in a very not high rate, it gives you energy extremely fast. So it gives you 2 ATP. Now, gives you 2 ATP. Now, one thing that I'm going to take time to explain, because I know that you'll probably ask, or I guess she ask a question on it. When you go through glucose to pyruvate, well, forget lactic acid right now, but when you go from glucose to pyruvate to the Krebs cycle, you're using free glucose, which means this is free glucose, which means you ate it from your diet. It's just floating in your bloodstream, and you break it down to form pyruvate. Now, the process of bringing the glucose into the cell to get into the cell cytosol, we get into the cell, but then you have to convert the glucose to something called glucose 6-phosphate. Don't worry about the substrate's name. But you have to convert it to this glucose 6-phosphate so it won't leave the cell. Because just like how glucose enters the cell, glucose can easily leave the cell. Now in the body, now going back to money, I guess, because that's the easiest thing to compare it to. In the body, the body can store glucose into a storage form called glycogen. Now think of glycogen like a bank account. It's a storage form of glucose, and glucose can be used for energy. So glycogen is essentially like 60,000 glucose molecules. I guess pick a number. Don't go with that number. It's a shit ton of glucose molecules just fused together. So we need energy. It's like energy in reserve. It's keeping the energy there. Just like a bank account, hopefully it's keeping your money for a future purpose. So it's the same thing with glycogen. It's keeping your money. Keeping glucose in a storage form. Now, what is the benefit of using, now, if you use glucose from glycogen, if you just break off the glucose molecule from here, compared to if you just use free blood glucose I just ate, there's a difference. The reason being because if you're breaking off glycogen is already in the cell cytosol. Glycogen is already inside the cell, so it doesn't have to form glucose 6-phosphate. And the whole purpose of this, instead of just memorizing everything I'm saying, is that glucose forming glucose 6-phosphate has a negative ATP. So if you use free glucose, remember free glucose is not in the cell, you have to bring it into the cell, has to form that glucose 6-phosphate. Don't worry about the substrate's name. That takes an ATP. So you lost an ATP to do that. So you gave up energy. Whereas glycogen's already in the cell, it doesn't have to form glucose 6-phosphate. Well, it does, but it goes right directly to glucose 6-phosphate. So in that instance, you don't have a negative ATP step. What the hell does this all mean? This means in the very, very last step where you form a set amount of ATP, spoiler, the very last step, you form 38 ATP. Or if you go through slow glycolysis, you form 38 ATP. If you go through glycogen, if you break it from glycogen instead of blood glucose, you form 39 ATP. Reason being because glycogen, you don't have that negative ATP step, so you have one more ATP. Now, I'm sure I'm just rambling, this does not make any sense, but when you break down the final process and see what anaerobic or aerobic respiration is, this whole process will make sense. Now, very fast, you go from glucose, free glucose gets into the cell, whatever, goes to pyruvate. We'll focus on pyruvate forming lactic acid for now. Lactic acid, that's 8 anaerobic respiration. The whole process is you get a whopping 2 ATP out of it, or a net of 2 ATP. So you got 2 ATP. This whole process is extremely fast. Now, one question or one thing to know is why do you actually form lactic acid? Now, some things we went over is if you need energy extremely fast, that is true. When you need energy extremely fast, you do form lactic acid. Another same word for the same thing we just said, anaerobic respiration, or not respiration, anaerobic glycolysis does use lactic acid because you need energy extremely fast, but this doesn't explain why you form lactic acid. That's a consequence during fast glycolysis. You do form lactic acid because it gives you energy, but that's not why you form lactic acid. There's a deeper reason why you form it, and that's important to know. Oh, fuck. Erase everything. Okay, so you got pyruvate. We'll just skip some steps. Nope, can't do that. Can't skip steps. Okay, glycolysis. Fancy steps. Pyruvate. Pyruvate forms lactic acid. And you form a net of 2 ATP. Why did you form lactic acid? The reason you form lactic acid is because breaking down the steps, if you took metabolism, you remember this, it would be easier to see, but breaking down these steps, at one point in this process, your body uses something called NAD, which is electron carrier, which we'll go over in the next video. It uses something called NAD to form one of its substrates into something else to continue the process to form pyruvate. And that process takes NAD and forms NADH. Now, your body only has a certain supply of NAD in the cell cytosol. You only have, say you only have 6 NAD to make this very simple. So you have 6 NAD. So you run glycolysis, or you run this cycle, you form whatever, you go through 6 times and forming pyruvate. Well, now you're out of NAD. If you're out of NAD, you can't continue this cycle because one of these steps requires NAD to form to NADH or to form pyruvate. So this whole thing is if you're missing one thing, you can't do the next thing. So you're missing NAD, so you can't form pyruvate, so you can't keep the process running, and thus you can't form energy. Everything will stop. So that is, well, luckily, the process of going from pyruvate to lactic acid takes NADH and reforms NAD. So you're probably thinking, oh, what's the point of that? Well, the point of this is, now that you reform that NAD can be used back in this cycle and keep the cycle running. Now, this is a really well-coordinated process in the body, beautifully coordinated if you think about it, that you use this NAD to form pyruvate. You have to reform that NAD, so you form pyruvate to lactic acid. That's the real purpose of forming lactic acid, to regenerate that NAD to keep the cycle running. Not to give you energy extremely fast. That's more like a side effect of forming NAD. But the whole process is really to do this, to form your NAD so you can keep this cycle running and form more pyruvate. Now, eventually, another side effect of forming lactic acid, that's the side effect of forming, that's why you form lactic acid. Now, a side effect of lactic acid is 1, 2 ATP, that's good. Another side effect is it's very acidic. This is, I'm sure everyone knows this. if you have a lactic acid buildup, if you don't remove it fast enough, we'll talk about different processes to remove it from the body. But if you don't remove it fast enough and it builds up, your body converts it to something that's very acidic. And over time, since it's so acidic, your body doesn't like acidity. It makes the environment a very non-friendly environment, and thus it stops muscle contraction, causes a burning sensation, whatever. And it stops exercise. But that's the real reason of why you form lactic acid. So that's why lactic acid is formed, in order to regenerate that NAD. And I can guarantee you that, I can say that's probably going to be a question, but it's a new teacher, I don't know. So next video we'll go over the Krebs cycle, the other path to take.